I think we have everyone on board. First of all, thanks for having me this conference. This is a huge privilege and honor to me to talk to you about a topic that I'm very passionate about. So before we start with the actual technical content, I'd like to know how many of you have never used Angular so far. And I mean the new version of Angular. Hands? Okay. How many of you have played with Angular but haven't written a production code and haven't earned money from it? Okay. And how many of you use Angular on a daily basis? Okay, so the majority here. So hopefully we'll have something for everyone, and we have a lot of things to go through. So I will be around, so be sure to check out with me after the session. So a few words. I'm Dennis. That's how you can find me online. I like to hang out on Twitter and on GitHub. And as well, I have a small personal page. I work for a company called Prevalent, where I develop a platform for third-party risk assessment. I also spent a few years as a consultant, consulting and training teams on Angular, primarily in the US, but also in Western Europe. So the topic of our talk today will be scalability, and I know that this means different things to different people. But I want to note at the start that this is not only about servers. So it depends on the size of the application that we're building. It depends on how many team members we have on board, the type of projects, and of course the business case that we have. But during development, we can have a certain problems that we need to tackle when we work. And the first one, and probably the one that we deal on a daily basis, are dynamic requirements. So we want a project that's easy to change. We want features that are easy to implement and also easy to integrate with the existing code base. We have to deal at some stage with an increasing load, and by load we mean heavy user interaction. So we want to build an application that scales in terms of rendering. We also have a growing complexity because each time we add a new feature, we add complexity to our code base. So we want to be able to deal with it easily or as easy as we can. And the last part is developer turnover. As you know, we work in teams. Sometimes these teams can vary in size. We can introduce new team members or we can replace team members. So we want to build a code base which will be easy to accommodate new people on our team, and they will be able to quickly get on board and start and be productive and deliver value to our product. So we got a slide about software design, and so I want to tell you why it's important. So this is the diagram from Martin Fowler, and you can find the article on his website, where he discusses that usually the design activities take up time and effort, but the argument here is that they pay off in the long run. So we can save short-term time, because we can see here, by not investing a lot of effort in design, we can actually deliver features quickly at the start, but at some time in the future, we can see that actually a good design pays off. And I know that for everyone, good design means different things. So here we are dealing more with the abstract concept of good design. I would recommend checking out this article, which dives a bit deeper on this topic. And this is a book that probably most of you are familiar with. And we know that the only correct way to write JavaScript is what we were not doing last week. But we want to change that. We want to create a code base which is scalable and which stands the test of time. And as we know in the JavaScript world, this is something that has been quite difficult to achieve. But I'm sure that we are moving towards the right direction. So that's our end goal. We want to have a modular application and to have a single responsibility, atomic modules, which comprise the features of our app, We want to have a predictable state management. That means that we need to have a good pattern to manage the state of our UI and propagate changes between different application components. We want to have a data flow architecture. That means we need to set a guide on how to define the way our data flows through our app. And also we need to have a capacity to handle increased load. And also we want our application to be easy to test. So we're going to cover in this presentation each of these parts, and we'll see an example ways to tackle all of them, so we can end up with some more quality code. So before I start, how many of you have used TypeScript or are familiar with it? Quite a few hands. That's good. So long story short, TypeScript is a language which extends the syntax of JavaScript. It transpiles to JavaScript. That means that if you run JavaScript code through the TypeScript compiler, it will emit the same code. And also in TypeScript, we can use features of the latest standards of JavaScript, and it can transpile it to something that our browser can understand. So for those of you who are not familiar with it, quick slides. Can you see the code well? I hope the contrast is good. Good. So this is an example, an example TypeScript code. As we can see, we have a very, very basic implementation of a queue. So first of all, I want to focus on the types. We have built-in types in TypeScript, so we can give types to our variables. That means that we cannot reassign a different value to this variable. We have generics. That means when we create a data structure which works only with this certain type, we cannot use the API of our data structure with a type that's not specified in it. So that's cool. Also, some of the additional features, we can use some more latest syntax of the language. So you can see that basically these two methods are the same. The difference is that here we use a different flavor of method declaration in JavaScript, and it will get transpiled to something from which our browser understands. Next, I want to talk about RxJS, and this is getting very popular lately with regards to single-page applications. So how many of you have used RxJS or are familiar with it? Good. So long story short, RxJS is a set of libraries which allow us to compose a synchronous and event-based program using observable sequences. So I know that this sounds a bit abstract. So the concept of an observable is something very simple. We can think of it as an array whose values arrive over time. And that way it helps us manage asynchronous data, such as, for example, data coming from a remote service, or we can have a user interaction, like key presses, mouse clicks. All of them we handle as observable sequences, which we can apply some transformation. So this is an example of an observable. As we can see, we use a simple constructor, and this observable will emit 4 values over time. 3 of them will be synchronous, and the 4th will be emitted after 1 second. So if you want to consume an observable, we need to subscribe to it. And basically what we do is we provide a function as an argument, which will be invoked each time when this observable emits a new value. So that's, in very simple terms, how RxJS works. We have different operators for RxJS. For example, with this thing here, we can emit numbers from 0 to 10 over the course of 10 seconds. And on this observable sequence, we can apply some transformations. So for example, here you can see that we have a typical RxJS operator, which is filter. A filter is a higher order function, which means that this is a function that takes another function as an argument and returns a new function based on the argument that we have provided it. So for example, right now, when our observable emits a number, this operator will check if the number is divisible by 2, and if it is, it will transmit it forward to the pipeline. The next operator, for example, which is very commonly used, is map. Map will do a simple projection to our data. It will take an item which is emitted by the observable, and it will do some transformation. In our case, it will just square it. And the pipe operator is the most important one, which basically chains the two higher-order functions together in order to create a single transformer which we can use. So I want to show you a small demo for RxJS before we proceed, because graphically it's always easier. For example, we have here an interval which will emit certain values. So if I decide, for example, this will emit, oh, you cannot see it? Okay, I'm sorry for that. Let's zoom in. Okay, so we have an observable. If we decide, for example, to just take the values from it, and we decide to visualize it, oh, that's not good. Okay, so let's see now. Over the course of 5 seconds, our observable emits 4 numbers, right? And if we want to make a transformation, what we have to do is, okay, this is challenging. Let's import an operator, which will be map. And we want to chain it so that each value that our observable emits gets transformed by our projection function. So I can type map x goes to, for example, x plus 1. So if you want to visualize it, how it works, you can see that we have incremented our numbers by 1 each time when this observable is emitted. So what we have to take from this is that with RxJS, we have an API which we can consume, and we can also transform observable sequences that get delivered synchronously over time. Let's go back to the slides. So I guess most of you have used the promises. It's not a new concept in JavaScript, right, to handle a synchronous data flow. So the differences between an observable and a promise, yeah, both of them are asynchronous. Both of them return values in the future. But the difference is that the observable emits a collection over time, multiple items over time. It can be lazy. That means that we can start consuming our stream of data only when we have subscribed, and we can also cancel them. So that's it. I want to show you a sample application which we are going to dissect today and see how it's built. I'll provide the demo online right after the session. So we have an app where we can post some trainings, and we can have instructors who can apply to deliver these trainings. And we can administer this app. We have several screens. It's very simple. Let's go and see it. So you can see we can go, we can toggle the state, we can delete them, we can create new ones, and so on and so forth. So with our application, I want to demonstrate a sample architecture that we're going to follow through to build this app. In very simple terms, we can distinguish it in 4 segments. So we start from top to bottom with our UI components. Our UI components talk to a facade or a wrapper, an API around on top of our business layer. And at the bottom, we have 2 modules. The first one is the state management module. So these are our classes and our functions that manage the state of our UI. And the second is our data access, which is a module which handles communication with remote services, different protocols. Here we also deal with different payloads because we can have multiple endpoints from multiple sources consuming different data formats. So this is the place we have to unify these things. So I want to start with the UI components first. So we can separate the components in Angular in two. We have presentational components and container components. So the presentational, you can find them in literature as dummy components too. They have a single responsibility. They take the data as an input, they render it, and when they listen for some events by the user, they notify the container, but they do not handle events themselves. So they basically emit events on top of the hierarchy. So the member who's responsible for these components knows how to render them. So the containers, on the other hand, they talk to our business layer. They handle the events. They know what to do when some event occurs. And this event is being raised by our dummy component. And it also knows where to get the data which to pass to our presentation component. And we can see this clearly in this diagram here. So we have our business layer, and our container communicates with our business layer. It knows where to take the data from, and then passes the data to our presentation component as an input. And the same goes on the other direction. When some event occurs, the presentation component notifies the container, and it then talks to our business layer about what needs to be done. So suppose we have this, the following UI. You can see that on the left-hand side, we have a simple list component, and on the right-hand side, we have a simple details component, and they are both wrapped around one container. So graphically, this is how the layout of this page works. So here we have presentational components, and they're wrapped around a smart component which knows what to do and where to get the data from. So this is the code, for example, for our course details. As you can see, we get the data as an input, and when some event occurs, we emit the output to our container component so it knows how to deal with it. So these are the ones that we want to focus on, and these are the things that a presentation component should contain. Whereas our smart component does a little bit more. You can see that it's, first of all, it knows where the data comes from, the sources of the data. It also communicates with our business layer, and it has, so when an event occurs, of course, our component knows how to deal with it. In terms of a template, this is, that's how it looks as a layout. You can see that here we have our dummy component, and we pass it a data, which is a stream. And it goes the same with the details component, where we pass the data, and when we listen for an event, and when an event is raised, we basically know what to do. So another thing is the async pipe here, which might be a bit confusing because it does a lot for us under the hood. So basically, the async pipe subscribes to an observable or to a promise. And when this observable emits a new value, it marks the component to be checked for changes by the Angular change detector. So that's what happens. The next part of our architecture is our facade, or our business layer, and this is inspired by the Gang of Fours facade pattern. So basically, that's an object that serves as an interface and masking more complex underlying structural code that we have. So what do we mean by that? Suppose we have the following system. Our client classes, we can think of them as our smart components. And below, we have all kinds of modules, async services, state management, and whatnot. So by having this kind of layout, we may stumble upon lots of problems because we can mismatch the dependencies and our code can become very difficult to follow, and that requires us to introduce the following member and the following layer, which can provide a clean and a simple interface for our components to communicate with our state services and with our sync services. So let's see how does it look. This is, for example, our a service which wraps our state management APIs. And you can see here, we'll go through that in a bit. It injects the store, which the store handles the state of our application. And each time we invoke a method, it does a query to the store, or it dispatches an action to the store. So basically, we don't have to do all of these selectors in our components because it's easy to get wrong, and it also should not be a responsibility of our components to know where does the data come from. So again, we inject our store to our state service, and we interact with the store of our application using this state service. Of course, in a large-scale app, you might segment it. You might have several services to interact with the state, but that's not the case for our demo today. So we want predictable state management, and what do we mean by that? This is the bottom left rectangle of our diagram. So I want to talk to you about Redux. How many of you have used Redux before? Okay, we have some few people with Angular. NGRX. Cool. So basically, Redux is a design pattern. It's not tied to any framework. And it basically solves a long-standing problem with single-page apps, which look like this. When we don't have Redux, we might easily end up in the tree which is on the left, where we have a component which depends on some data or has some UI state, but when the state updates, we might want to notify a component which is on a different branch of the tree. And this usually ends up very badly, and we have to write lots of bad code. For those of you who have used Angular 1, there was one like scope digests, like stuff, you know. So when you write it, you kind of hate yourself, but you have to do it because otherwise it doesn't work. So we don't want that. With Redux, we have a simple store, and the solution for this is basically we store all of our application state into this store, into this one single object. And when a change happens, we dispatch an action to the store. It knows how to update. And when an update is finished, the other components that depend on this piece of data or this slice of our store get notified, so they re-render. And that way we have predictability, and we'll see also how to significantly boost performance using that kind of structure in our app. So these are the three underlying principles of Redux. First of all, it's a single source of truth because our app state is on one place. The state is read-only. That means we cannot make modifications to it because it's immutable. And we also, all of the changes to the state are made with pure functions. So a pure function is, it comes from mathematics, but in simple terms, it's just a function that has the following properties. So the return value of a pure function is the same for every time when it's invoked with the same input values, and it does not mutate the outside state. It does not depend on some global variables which are outside of its scope. And that's a very important concept to remember when we deal with Redux. So for our example, we're going to use NGRX, which is basically a Redux implementation for Angular, which steps on RxJS, which we already saw. So we can separate our state management into these 5 modules. So we have the store, reducers, effects, selectors, and actions. I know that that sounds a bit overwhelming, but we'll see what it means. So some terms. The state is a simple JavaScript object which holds the application data structure. So we can store the data in the state in order to display it in our components. And it's also important to have a single store, because we can have multiple mutation sources. We can mutate the state of our app using browser interactions, remote services, and whatnot. So it's very important to manage it through a single, at a single place. We also have a view which represents our state, but in the DOM. We have an action, and the actions are objects describing events, and they are used to send information to the store. We'll see how this happens in a bit. The reducers are functions that produce a new state, basically, because our state is immutable. So we invoke a reducer, giving it a action object and the old state, so it returns a new state. A selector is a function that reads from the store. And an effect is a middleware to run side effects analyzation. I know that it sounds a bit abstract, but we'll see it in practice how it works. So that's a simple diagram of how our component updates with Redux. So the state can be changed only by dispatching an action. And every change is propagated to every subscribed observer of this change, and there is only one instance of the state for our app. So when we have a modular application in Angular, each module can introduce a separate slice of the state. So let's see what happens. We have a component. This is a smart component which talks to our business layer. We create an action. This action is dispatched and it arrives to the store. So the store applies the reducers, which will take the action. They'll take the payload or the data from this action, and they will return us a new state, and this new state will be saved at the store. And then our store will just call like observer next, and this will not notify the components that have been subscribed for changes inside our store. So, for example, in our app, this is a simple. This is the shape of our state because it's very simple. We have a list and a list of courses and a selected course which we hold at the state. These are our actions. As you can see, actions are simple TypeScript classes. An action has a type, and it has a payload. But the payload is optional because some actions can be like void. So what happens now? You can see, of course, this is some TypeScript syntax here, where we use types to describe our actions. In some of the examples, you can see it otherwise. And this is our reducer. So the reducer is part of our state, and you can see here that, first of all, it's a pure function. It accepts two arguments, which is a state and an action. And given this state and an action, our reducer will update our state, or basically will create a new state based on this action and return a new instance of it. So, for example, this is how our component works. This is our smart component, and it has subscribed to changes in our state. And this is part of the state where we store the selected course, which, if we go back, is exactly this property. So every time we update the state, and for example, we select a new object for our selected course, our state will be updated, and because we have subscribed to the changes inside this part of the state, our component will be notified immediately, and it will know when to re-render its layout. So again, I want to focus on this because we work with observables. We don't work with references. And in our template, we focus on this type of data binding, which is one way. And we use the sync pipe to tell our component that it works with an observable and not with a direct reference of some value. So how do we manage side effects? So in computer science, the term side effects, or a function or an expression which has a side effect, that means that it's modified some state outside of its environment. So it has to say, for example, it touches a variable somewhere outside the scope of our function, or in our case, a side effect can be also a remote HTTP call. So how do we handle this with Redux? And we have a bit more complex diagram here where the effects come into play. So as we can see, we have our login component. We have invoked the login method of our Facade, of our state service. So our state service dispatches a new action, which is called login action, and it provides as a payload the credential that we have inserted in our form. And then it gets intercepted by the effect middleware. For those of you who have used NGRX, do you use effects or you handle it differently? So when our action gets intercepted by an effect, we can then communicate, and we can do it in isolation. We can communicate with our remote API by calling its method. So now this is part of our data layer, and the authentication API, for example, knows when to make a request or where to make a request. And when we get the response, we go back, and our effect dispatches a new action, which we'll call login success, for example, and has the payload with the user data. And this action is dispatched to the store, and then the store knows how to update by applying the reducers, updating the state, and notifying the components. So in short terms, that's how it looks. When we use effects, that's for example, an example effects class. I know that it might look a bit scary at the beginning, but it's actually pretty simple. So what we do here, and this is called a filtering decider. So this basically will intercept an action which has been dispatched, and it takes the action's payload, and here we run our side effect code in isolation. So we call our remote service. We get the data back, and after that we return a new action which gets dispatched and gets processed by the store. So long story short, that's how it works. This is our reducer. For example, now when we have dispatched the login action, we can apply, we can return the new state with the required variables that describe what's going on, so we can reflect it in the UI. And when we dispatch the success action, now we return a new state with the payload which we've got from the remote service, but of course the reducer is not aware of that. So the last part is the data access, and this is the layer where we handle our interaction with remote services. So we can have several gateways like HTTP, WebRTC, WebSockets, and we can also deal with different payloads. So this is where this should happen in this layer, and usually the way it's done, it's by introducing simple TypeScript classes where we can encapsulate this logic, and I'm pretty sure that most of you have used them. For example, this is a very basic service that communicates over HTTP with some backend, gets some data and returns some data. And the last thing about Redux that I think is pretty cool is the ability to debug our application, because every time we have a new instance of our state, that means that we can easily reason about the state which our application is in. So if we go back, and for example, we trigger the, okay, can you see it? No. So we have this thing called Redux DevTools. So, and it exists as a Chrome extension. So if we go here and type Redux, you can see the list of all the actions that have been triggered in our system. So let's start from the beginning. If I refresh the page. So you can see here that the first action that happened is our login redirect. So if we decide, for example, to log in, you can see the actions that have been invoked in our system. And each time we change, we basically can see the shape of our state and how it has changed. So for example, when we trigger the login action, we have this flag, which is part of our state, has been updated. So for example, this is useful if you want to create like loading indicators, for example. So when we have login success, this is how our state has been updated. And after that, we have loaded our courses. And you can see that currently, because it's an HTTP call, our state is the same. But after successful load, we can see that we have actually loaded our items. And the coolest thing, and that's why it's called a time-traveling debugger, is that we can jump through different state of our applications. So if we go and see, for example, that's the structure of our UI right now. And on the left side, that's what we display. So that makes troubleshooting very easy and the debugging very easy, because sometimes if something does not display, most of the times we don't know what's it about, because it can be some Boolean variable hidden in some component that didn't get updated. So that's the coolest part of Redux, in my opinion. Let's go back to our slides. Do you have any questions so far on Redux? Yeah?
This was the happy scenario when the login succeeded.
Mm-hmm.
What if the login failed?
We dispatch a login failed action. And inside our reducer, we basically transform the state with regards to what we want to happen when the login fails. It's the same pipeline. Yeah, it's also one effect. It's actually the same effect. I just wanted to be concise, not to overwhelm. But when you see it here, so we can provide a second function which will contain the error handler for us, and the second function will just emit a different action. It's the same thing. Okay, so let's talk about change detection. So in Angular, by default, the framework separates updating the application model and reflecting the state of the model into the view. And our responsibility is, as a developers, is to update the application model, and the responsibility of the framework is to update the view. So these are two different things. And the way change detection works by default is that when we have like a browser event, for example, or some remote service call completed, it goes through each component, because each component has its own change detector. And each of these change detectors run their bindings and check for updates. So for example, if I update my details component in our case, the framework will traverse the whole component tree. It will check for updates. And it will re-render the UI of our app. This is not that bad as it sounds. Usually this is quite fast, and for most of our application, using that kind of change detection is enough, and it would be okay. But I want to talk to you about another way of enforcing change detection in Angular, and that's by using immutable objects. So what do we mean by that? If our model, application app state, uses immutable objects, like in the examples above, we can tell a lot more about when a component should change. That means a component should change if and only if any of its input changes. And then we go back to our presentation components, which basically render our data, and they take their data as an input. And we can tell Angular that we want our components to get re-rendered only when we get a new reference pushed to the component as an input. So let's see how this works. This is our dummy component, which we already saw, the details component. And here we have a configuration in the component decorator. We can say change detection on push. And that will inform Angular that this component only depends on its input, and any object that is passed to it should be considered immutable. That means each time there is an update, we'll get a new reference or a copy of this object. So this time, when, for example, we select a course from the list, nothing will change on the list view because we're updating only the details. And that way, for example, Angular will check for changes and re-render the UI only of this node of the tree and not of the whole component tree. So that's a quite powerful stuff. So this change detection strategy, of course, should be used carefully. We should know what we're doing, because if we do not update our state correctly, we can end up like updating our state and not having our components reflect these changes. So that way, we tell, okay, if the input gets a new reference, we re-render, otherwise not. So we skip the checking. Last part is the modules. Basically, the modules in Angular are packages for code reuse. In modules, we can have like components, services, pipes, directives, and it's always good to segregate it in terms of features. So basically, we can have an app module which bootstraps our application. It's also a good practice to have one shared module which contains like directives and pipes, which we are going to reuse in some other modules. And we also separate the features of our app into their own modules within their own components, and own pipes and own services. And let's talk about a bit about lazy loading. And this is something that I think everybody should do because it's too easy. So this is our app when we load it. And suppose we have a module which is lazily loaded. And this is very easy to do using the Angular's router. And this is a practice that I would certainly recommend, because usually we have different roles. And for example, if you have an administrator who can see a large area of our app, it does not make much sense to load it every time when a normal user logs in. So this is another optimization that's very easy to do, and it pays off big time in the long run. So let's see what we did. We have a modular project with feature modules and lazy loading. We have a predictable state management using Redux. We can handle increasing load by using immutable objects and change detection on push, that way achieving fast rendering. We also can handle easily async data flow using the RxJS streams and transformations. And also our app is easy to test, which kind of comes for free because of the Angular's DI and the fact that we can easily mock our services when we abstract them into our business layer. So that's it. That's a sample tech stack. Obviously, TypeScript, RxJS. You should check out NGRX store and effects. And for immutability, I would recommend you checking out Immutable.js library and see how you can model your app state using it. And one final thing, everything that we talked about so far does not replace common sense. We might not need Redux, we might not need immutable objects, and we might not need change detection on push. So it's always depends on the business case that we have. It always depends on what we want to build, how long it's going to live, and what's the purpose of it. So always take everything with a grain of salt and take decisions based on your own competence and not on popularity. Because in our industry, I think that popularity is growing a lot, but we should always include our own reasoning and mix it and try to come up with the best solution. One final thing, this is the Reims Cathedral in France, in Reims. So most of the cathedrals in Europe, they show differences in the architectural styles because they're built by many generations. So each generation tries to incorporate their own ideas into this design. But usually this cathedral stands out in a contrast with that because the integrity of its design was achieved by a kind of self-abnegation of 8 generations of builders, each of them who sacrificed their own ideas in order to create the pure design. And I know it gets biblical a bit, but usually that's the message that it sends, that this does not only proclaim the glory of God, but also his ability to salvage man from their own pride. So I want to finish with this quote from the mythical Amendment. It's always better to have a system amid certain features and improvements, but to follow a design ideas to reflect design ideas than to have one that contains many good but independent ideas. So every time we inherit a code base, we should keep that in mind. A few references for you, and these are a few articles that helped me when I was preparing for this presentation. They're quite cool, you can check them out. I want to emphasize on this talk, Making Architecture Matter by Martin Fowler, which was very influential to me. He does not talk about Angular or JavaScript at all, but it's more abstract. And with that, I want to say thank you. And we have some time for questions. If you, yeah. If not, I think we can wrap it up. I will be around, so feel free to ping me or find me online if you want to discuss something. And again, thank you very much for having me today.